In Lesson 4, we'll be talking about empirical and molecular formula calculations. So we're going to understand what is an empirical formula, and then we're going to go over the rules and steps on how we can determine our molecular formulas. So the first thing is an empirical formula, which we learned in bonding, is the simplest ratio in which atoms or moles combine to form a compound. This means that you're going to always divide subscripts of the two elements that you have by the greatest common factor. So what does this mean? Let's look at some formulas. Whenever we have an ionic compound, we will always write them as empirical formulas. We always write them as the simplest ratios. So if you have Fe2O2, we can simplify, because 2 to 2, you can simplify this to FeO, a 1-to-1 ratio. If you also have aluminum phosphate, where you have 3 aluminums for every 3 phosphates, they can also be simplified to just a 1-to-1 ratio. However, when we do covalent molecules, they can always be simplified to their empirical formulas, even though it may not show their true molecular formula. So if you have C2H8, the greatest common factor between these two numbers is 2. So if you divide everything by 2, you get CH4. If you have C3H12, the GCF is 3, so if you divide everything by 3, you also get CH4. In some situations, the empirical formula can be the same for many different molecules.
Now again, remember, empirical formulas are the simplest ratio. So here are a couple of examples that we're going to want to change from their given molecular formulas into their empirical formulas. Okay, so why don't you pause the video and try to do these on your own.
If you're noticing that there is no empirical formula or the compound is already in its simplest form, just simply rewrite it as the simplest form.
So here are the empirical formulas. N2O4, you could divide them by 2 and get NO2. BaCl2, which is ionic, so already in its empirical form, is just BaCl2. C2H6 can be simplified to CH3. CH3 is already in its simplest form, so it is still CH3. Ca2P3 is Ca2P3 because, again, ionic compounds are always empirical. C8H18 can simplify to C4H9, and glucose C6H12O6 can be simplified to CH2O. Again, a molecular formula and an empirical formula, not always the same, but can be the same.
So molecular formulas are the true formulas of covalent molecules. Using the empirical formulas and given molar masses, which is the gram form of the mass, you can determine the true molecular formula, which is not a simplified calculation. So there are 3 steps, and they're very easy to do. They are, however, not on the reference table, so you must memorize these steps. The first step you have to do is calculate the gram formula mass of the given empirical formula. You then will take the molecular mass, which is always given to you in the question, and you will divide it as the numerator to the GFM of the empirical formula. You will then get an answer. That answer we call the multiple, and you will use the multiple to multiply all the subscripts in the empirical formula by that number. What does this mean? Let's show you some examples right now. The empirical formula for ethylene is CH2. That is our empirical formula, which we could say is in step 1. Determine the GFM of our empirical formula. That means you take 1 carbon and 2 hydrogens and you get 14 grams. Step 1 is done. Step 2, divide the molar mass by the empirical formula. It says in our problem, find the molecular formula if the molecular mass is 28 grams per mole. That means you take 28 grams, you divide it by 14 grams, so it means you take the molecular formula mass, divided by the GFM, and you get the multiple of 2. The multiple of 2 means you take our empirical formula, which is CH2, and you multiply all the coefficients by 2, which means you get C2H4. That is our molecular formula. So to check yourself, you could say that 2 carbons, which is 24, plus 4 hydrogens is 4. 24 plus 4 is 28, and that is also our given molecular mass.
The empirical formula of a molecule is NO2. Find the molecular formula if the molecular mass, or the GFM, is 92 grams per mole. So again, first we're going to determine the GFM of the empirical formula. It's 1 nitrogen, 2 oxygen, gives you 46 grams. Then we're going to take the molecular mass and divide it by the empirical formula. So 92 divided by the 46, which gives you a multiple of 2. Then you take the subscripts of the empirical formula and you just multiply them by 2. So there's 1 N, you multiply that by 2, you get 2 N's. 2 O's multiplied by 2 gives you 4 O's. So now the new formula is N2O4. To check, you just add up all the substances that you now have in your molecular formula. So 2 N's plus 4 O's, and it should come out to the same molecular mass given in the problem.
Now, we want you guys to pause the video right now and try this problem on your own. Okay, I'll read it off to you. The empirical formula of a molecule is CH3O. Find the molecular formula if the molecular mass is 93 grams per mole. So, using the 3 steps that we give you, figure this out on your own. For step 1, you should got 31 grams. For step 2, you should got a multiple of 3. So you take our empirical formula, which is CH3O, and you multiply it by 3, and you should get C3H9O3. And if you check yourself, you should get the math saying that your molecular mass is still 93 grams. So to summarize everything that we've talked about, the empirical formula is again the simplest ratio of which atoms combine to form a compound. That would be the simplified formula on the bottom right-hand side, while the molecular is the actual ratio, which is what we're noticing on the lower left-hand side. Both of these are considered sugars. The one on the left is the true formula for a sugar, but the empirical formula on the far right-hand side is a basic example of what a starch molecule is.
Again, we cannot stress the fact that a molecular formula and empirical formula will act differently, but they have the similar compounds in simplest ratios.